Hi everyone, my name is Nur Hafiza Atika binti Surji and my matrix number is D202010957002. So I am going to show you how to solve the problem by using Gauss-Seidel method. The equation given here is 5x1 minus 2x2 plus 3x3 equal to 1, negative 3x1 plus 9x2 plus x3 equal to 2, and the last one is 2x1 minus x2 minus 7x3 equal to 3. Before we start, we need to write the equation in the form of x1 equal to negative 1 plus 2x2 minus 3x3 over 5, x2 equal to 2 plus 3x1 minus x3 over 9, and the last one x3 equal to negative 3 minus 2x1 plus x2 over 7. So we need to use the initial approximation here to substitute it into the equation above. So we have x11 equal to negative 1 plus 2 times with 0 minus 3 times with 0 over 5. And the answer is negative 0.200000. The next one, we need to substitute the value of x1 into the x2 equation. So we have x21 equal to 2 plus 3 times with negative 0.200000 minus 0 over 9, and this solution giving answer 0.155556. And then we need to substitute the value of x21 into the equation of x31. So we have x31 equal to 3 minus 2 times with negative 0.200000 plus 0.55556 over 7, and the answer is 0.507937. So we need to continue the same procedure until we obtain at least two successive approximations which are identical as shown in the following table. As we can see in the table, the equation already converged at n equal to 8 here, and this solution is giving the answer of x1 equal to 0.186120, x2 equal to 0.331230, and the x3 equal to negative 0.422713. That's all from me. Thank you.
Hi everyone, my name is Muhammad Nur Azwan bin Azman. So for today, I would like to show to all of you how to solve a problem using a Mathematica and Gauss-Seidel method. So first thing first, where we have the problem, like we have put in the linear system format, we want to change it into the matrix format. Then we insert it into the Mathematica, where is matrix A equals to bracket 5, negative 2, 3, negative 3, 9, 1, and 2, negative 1, negative 7. This is matrix A. And then B, the right side, which is negative 1, 2, 3, and the initial value is 0, 0, 0. So first thing first, we want to find the diagonal of matrix A. We denote is at D1. Which is we will get 5, 9, and negative 7. And D2, we introduce it to make the diagonal into the matrix form, where is 5, 0, 0, 0, 9, 0, and 0, 0, negative 7. Then we find for NL and NU, where is NL is lower triangularized and NU is upper triangularized. So we minus with D2 because we only want the lower part of triangular of matrix A without the diagonal value. So we will get 0, 0, 0, negative 3, 0, 0, 2, negative 1, 0. Same case as NU, we minus with D2 because we don't want the diagonal. So we have 0, negative 2, 3, 0, 0, 1, 0, 0, 0. And then we denote L and U equals to negative NL and negative NU respectively. we can ignore this, where we can change it at the formula that we want to solve it at the from the Gauss-Seidel. So this is Gauss-Seidel formula. So if we didn't want to introduce L and U, we can change negative L this to positive L, because negative and negative become positive, and U here we change it into negative and U. So we print it because we want to see the solution, and we want to check either it's converged or not. So this term n1 and 10, because we want to check it from n1 until n10. So this is the solution that have been solved. So as we notice, the value of x have converged at n equal to 8, where is x 8. So we see the x1 from x8, 9 and 10 is equal. Also same for the x2 and also same for the s3. So we conclude it as it is converged. Start at x8.
Good day to Doctor and my fellow friends. I am Ganpei-Ji, metric number D202020970888. Now I will present how to solve these questions by using Jacobi methods. Firstly, write the system in the form x1 equal to minus 1 plus 2x2 minus 3x3 over 5. x2 equal to 2 plus 3x1 minus x3 over 9. x3 equal to negative 3 minus 2x1 plus x2 over 7. Next, let initial approximation x1 equal to 0, x2 equal to 0, and x3 equal to 0. Then substitute value of each variable into system. Then we will get for the first approximation, where x1 equal to negative 0.2, x2 approximately 0.222222, x3 approximately negative 0.428571. Continue this procedure until we obtain two successive approximations that are identical as shown in the following table. For 6 decimal places, we can conclude that the solution is x1 equal to 0.186120, x2 equal to 0.331230, and x3 equal to negative 0.422713. That's all from me. Thank you.
Hello everyone, I'm Tiffany Evelyn Naabang with matrix number D2020109569. So now I'm going to explain about the Jacobi coding for SN1. So firstly, we're going to input the given question, which is A is equal to 5, negative 2, 3, negative 3, negative 1, 2, negative 1, negative 7, B is equal to negative 1 to 3, and for the initial value, which is x0 is equal to 0, 0, 0. We're also going to input the equation to identify the diagonal. So we input the D1 is equal to diagonal A, and after pressing the button Shift plus Enter, we're going to get the display matrices, which is 5, 9, negative 7. So next, for D2 is equal to diagonal matrix D1, we're going to get the display matrices, which is 5, 0, 0, 0, 9, 0, 0, 0, negative 7. Also for equation and L is equal to lower triangularized element D2, after pressing the button Shift plus Enter, we're going to get the display matrices, which is 0, 0, 0, negative 3, 0, 0, and 2, negative 1, 0. for the equation nu is equal to upper triangularized a minus b2. After pressing the button shift plus enter, we're going to get the display matrices, which are 0, -2, 3, 0, 0, 1, and 0, 0, 0. As in our previous study, we also need to input the given equation, which is for L is equal to -10L semicolon and for U is equal to -NU semicolon. Next, we're going to input the following code, and in this following code, we need to note that we're going to get the 6 decimal places, so we need to put 6 out here for the matrix form xn6, and we're going to try for the iteration until 15, so we're going to input 15 out here. So finally, after pressing the shift plus enter, we're going to get the following display iteration until 15. And finally, we get the two successive approximations and identical starting from the iteration 11. So finally, we're going to get an answer for x1, 0.186, 1 to 0, and for x2, we're going to get 0.331230, and for x3, we're going to get -0.422713. That's all from me. Thank you.
Okay, for now we want to compare for the handwriting Gauss-Seidel method and Jacobi method. So for the comparison, we look that the first step is the same step, which is we make the x1, x2, and x3 as a subject from the equation given. So here we will get the same equation for x1, x2, and x3 for Gauss-Seidel method and Jacobi method. It start to be different where we start to put the initial approximation. So as a Gauss-Seidel method, where we use the x2 and x3 equals to 0 for x1, we get the -0.2. For the x2, we use the x1 value that we find before, where is -0.2 into the formula at x2. Also goes to x3, where we put the value of x1 and x2 into the x3 formula. So for the Jacobi, we only use x1, x2, and x3 equals to 0 for all of the formula to find x1, x2, and x3. And then we recalculate it for n2, n3, and so on until it converges. For the Gauss-Seidel, we find it converge starts at n equal to 8. And then for Jacobi, we find it converge where n equals to 11. Okay, for the mathematical method for Gauss-Seidel and Jacobi, it's also same like handwriting one, where the similarity is from the few steps, which is for both method we used to find D1, which is diagonal and then diagonal matrix, and L lower triangularized, upper triangularized. We find LU, L and U, and then the difference starts where we put the formula for. We look for Gauss-Seidel, where the formula is D2 minus L in bracket U multiply with xn plus b. But for Jacobi, the formula is D2 L plus U in bracket multiply with xn plus b. And then we find it converge as same like handwriting one. For Gauss-Seidel, we find it converge at x equal n equals to x, but while Jacobi when n equals to 11. So as a conclusion, we can say that Gauss-Seidel is more convenient rather than Jacobi because it will less the time consuming and user friendly for the handwritten one. So that's all from us. Thank you.